Guys, welcome to video 1 of week 2 of your online classes. Our aim today is how do we interpret rate of change over a given interval, and your do now is given the 2 points, find the slope of the line below. All right, so throwback here because I'm sure you talked about slope all the way back in like pre-algebra, and the simplest way to look at it is that slope is the rise, how much we go up and down, over the run, how much we go left, right. So to get from point -2, -1 to the point 4, 3, we are going to rise up. From -2 we go 1, or from -1 we go 1, 2, 3, 4, and then we go over 1, 2, 3, 4, 5, 6. And pardon my bad handwriting as I use the touch screen for that. I tried to line them up with the graph lines as best I could. So we went 4 over and, or 4 up and 6 over. And then we've got our rise over run is 4 over 6, which simplifies to 2/3. So for rise over run, you can either rise up or down. If we rise down, or, go down, what does that give us? It gives us a negative number. But we always run to the right. We're going to read graphs from left to right always, just like we read books from left to right. And that's like the pre-algebra way of talking about slope. Once you got to Algebra 1, you probably talked about slope as change in y over change in x, or you might have seen it as that little symbol delta y over delta x, because that triangle delta means change. Or you could have gotten it as a formula, y2 minus y1 over x2 minus x1. And that formula is what we're going to want you to use in Algebra 2. And so when we say those x2s and those y2s, what we're talking about is we've got 2 points here, each of which has an x and each of which has a y. So we could think of this point as the first point, and so it gives us our first x value and our first y value, and we could think of this one as our second one, and it gives us our second x value and our second y value. And if you wanted to flip them around and think of 4, 3 as your first set of points and -2, -1 as your second set of points, that's fine. Either way that you plug them in, you will get the same answer out. All right, so then we're plugging into this formula. Our y2 is 3 minus our y1, which is -1, over our x2, which is 4, minus our x1, which is -2. So we've got 3 minus -1 over 4 minus -2, and that's 4 over 6, which simplifies to 2/3. It's really the same math that we just did by counting jumps to get rise over run. It's just a little bit more algebraic. And so now that we're doing this in Algebra 2, we're going to start talking about it as a rate of change. And you already know how to do it. You just call it slope. And to find the rate of change, you're finding that change in y over that change in x with that formula, y2 minus y1 over x2 minus x1. And for linear functions, that's really straightforward because for linear functions, the slope is the same all the way up the line. We could have picked any 2 points on this line. We've got another point there at 1, 1. We've got, and we could keep going. Any 2 points that we plugged into that formula would give us a slope of 2 over 3 because that is the slope of the line. And we say that linear functions have a constant rate of change. That's something that's in your guided notes. Make sure you get it down. Constant rate of change for linear functions. But what does it mean to find the rate of change on a curve? And I'm just going to mark a couple of the points on this graph that are easy to use. We've got one at -1, 1. We've got a point at 0, 0. We've got a point at +1, 1. We've got a point at 2, 4. Because I don't like to use fractions if we can use whole numbers. We'll just focus on those points. So let's find the rate of change using the point, see, we had a point 0, 0, and we have a point 2, 4. Let's use that one. If we find that rate of change, you know what? Actually, I'm changing my mind. We're going to start by using 0, 0, and 1, 1, which are both points over here. I've got 0, 0, 1, 1. So this will be our x1 and our y1. This will be our x2 and our y2. And let's just plug that in. Y2 is 1 minus y1 is 0 over x2, which is 1 minus x1, which is 0. And then that equals 1 over 1, which is just equal to 1. So for this portion of the graph from 0 to 1, we've got a rate of change of 1. But let's do this again with the points 1, no, I wanted it to be the smaller one, 1, and the point 2, 4, and see what we get. So now this is our x1, this is our y1, this is our x2, this is our y2, and I've got, you guys tell that that's a 2 there, and I've got 4 minus 1 over 2 minus 1, and that gives me 3 over 1, which is just 3. So for this portion of the graph, when we plugged it in, we got a rate of change of 3. But for that first portion, when we plugged it in, we got a rate of change of 1. So curves do not have a constant rate of change. The rate of change is going to change depending on what points you choose, which makes sense because another way to think about slope is that it's really measuring the steepness of the line. And if you look at that green portion of the graph, it's really much steeper than the blue portion of the graph beneath it. So it does have a higher rate of change. So because of that, it wouldn't make any sense to look at this parabola and say, oh, well, the slope of the parabola is 3, or the rate of change of the parabola is 3. No, the rate of change is not going to be the same. It's going to depend on what piece of the graph you are focusing on. And so we talk about the average rate of change, which means that we are going to ignore the curves that we have and just find the average slope on a given interval. And so what's the average rate of change of this table? We're now on a new function here. We've got this table that we're looking at. And we're going to look for the average rate of change on the interval -1, 2. We used interval notation a while ago when we did inequalities, right? But it's been a while, so let's just review how you read that. Those brackets mean that the numbers are included, and they're giving us here 2 x values. And what they're really saying is look at the average rate of change from where x is -1 to where x is 2. So they've given us our 2 x values, and we are just going to have to find the y values that go with them. So if we were going to write these rates of change that we already found in interval notation, this first one where we went from 0, 0 to 1, 1, we can say this graph has an average rate of change of 1 on the interval 0, 1, because we went from the x value 0 to the x value 1. And then the second one we did was from 1, 1 to 2, 4, and we could say this graph has an average rate of change of 3 on the interval 1, 2, because we went from where x was 1 to where x was 2. And so interval notation does not tell you the y value, it only tells you the x value. But once you have the x value of a point in a function, you can always find y. And so let's go ahead and do the average rate of change for this table on the interval -1 to 2. And it's going to be really easy in table form to find the y value that goes with the x. We're just going to look where x is -1, and the y that goes with that is -28. So that'll be our x1 and our y1. And then we've also got this x value of 2, and the y that goes with it is -1. So that'll be our x2 and our y2. And so then go ahead and plug that into our equation. What do you get? So we plug that in, we do y2 is -1 minus y1, which is -28, over x2, 2, minus x1, -1, which is going to give us 27 over 3, and 27 divided by 3 is 9. So we can say the function has an average rate of change of 9 over the interval -1, 2. But we have to specify the interval, because if we had picked a different set of points, we would have gotten a different rate of change. All right. So this is the type of question that you're likely to see on the Regent exam, where they don't just ask you for the average rate of change for an interval on a specific function, but they ask it for two functions, and they ask you to compare. So they've given us the interval -2, 4, and I think that you guys can pretty easily at this point find the y values that go with that on this table. But let's talk a little bit quickly about how you would find the y values that go with -2 and 4 for this equation. And there are really two ways to do that. The first one is that we have an equation here that tells us how to find y if we know what x is, and we can just plug our x value in. So I can plug -2 into this equation and say 4 times -2 cubed minus 5 times -2 squared plus 3. And I can pop that in my calculator and see that I get out -49. And then I can do the same thing a second time. So I know I've got the point -2, -49. And now I need to find the y value that goes with my 4. So I'll do 4 times 4 cubed minus 5 times 4 squared plus 3, and that gives me out 179. 179. So that's one way to get your y values when you're working with an equation. Personally, I'm lazy, and I think it is easier to just go into my calculator and take this. Oh, that's not what I wanted. I wanted a highlighter. Oh, or I'm highlighting black, not really my chosen highlighter color. I can just take that equation, that 4x cubed minus 5x squared plus 3, and I can put it into y equals, and then I can hit second graph. I can pull up the table, and I can look in the table at what y is when x is -2 and at what y is when it's 4. That just to me is a little bit faster. Either way works. So take a moment, solve for the average rate of change twice, once for the table and once for the equation. Okay, so if we plug that in, for the table, it's 80 minus 1.25 over 4 minus -2 gets us 13.125. And if you got this piece correct but got something different out of your calculator, make sure that you are either putting parentheses around the entire numerator and the entire denominator, or you're using that calculator trick of hitting alpha y equals to get a fraction into your calculator. And then for the equation, we did 179 minus -49 over 4 minus -2, and that gets us 38. So we found both average rates of change on the interval -2, 4, but we haven't actually answered the question yet. The question says, which function below has a greater average rate of change on the interval -2, 4, justify your answer. And on the Regent exam, when you see that word justify, it means you need to give a direct answer to the question, and then you need to give some kind of mathematical proof. So they're not so much making sure that you have full sentences and like a nice explanation using the math vocabulary. They just want you to show that you have a reason for your answer. So for this, you could put something like g of x, which is the name of our equation over here, has a greater average rate of change. And don't forget, you have to specify the interval. On the interval -2, 4, because it doesn't make sense to talk about the interval of, or the average rate of change of a curve unless you're talking about it on an interval. And then I could just say f of x. I could just say something like, because 38 is greater than 13.125. Bam, full credit on that Regent question. Try this one more time here. The distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. The table below shows stopping distances for various speeds. Determine the average rate of change in braking distance between one car traveling at 50 miles per hour and one traveling at 70 miles per hour. All right, this is a little bit tricky because they don't give it to us directly as an interval, but they tell us we're finding the average rate of change. And then what they tell us is that we're looking between one car traveling at 50 miles per hour and one car traveling at 70 miles per hour. And those are our X values. So we've got this 70 that goes with the 306.25, and we've got this 50 that goes with the 156.25, and we're just going to plug that. All right, so it is just 306.25 minus 156.25 over 70 minus 50, and that gives us 7.5. And then don't forget to include the unit in your answer if they give it to you. That's feet per mile per hour. All right, this was fun, guys. Try the Delta math, and hope I'll get to see you guys soon. Please feel free to email me with any questions you have. Bye.